Okay, today I'm going to talk you through day 2 of graphing sine, cosine, and tangent. And today we're mostly focusing on tangent. So I'm going to get to the right slide for you now. Okay, I previewed this the other day in class with what tangent's graph looks like. And roughly, it just looks like this. And it's supposed to hit right there at the origin. But tangent has asymptotes at pi over 2 and negative pi over 2. And it just keeps repeating itself like that over and over again. So I could draw another one here, etc. But let's talk about why it has those asymptotes. That's probably the best thing I could say about this. Tangent is sine over cosine. And so whenever cosine becomes 0, this tangent can't exist. So if you were to look at the cosine graph, it goes like this, and then it goes like this, and then it goes up here. And whenever cosine hits here and here, cosine is 0, and so tangent, this new function that I drew in black here, can't exist because there's asymptotes there. All right, so that's basically what tangent looks like. A couple thoughts about it compared to the other ones. Its period is only 1 pi, as opposed to the other guys got their complete cycle done in 2 pi's. These get done quicker, and there only takes 1 pi to get a full period of tangent. All right, so that does affect especially on the inside. So let's say that you had this tangent of 3x. Well, normal tangent graph, you'd always start by saying, okay, here's normal tangent. Just like the others, we always graph the parent one first. That's normal tangent. Pi over 2 here, and negative pi over 2 there. Okay, but this will make my graph different. And so the best way to think of it is where we say, all right, I don't trust this thing on the inside. I'm not going to just multiply everything by 3. I'm going to multiply everything by 1/3. Okay, so I'm going to multiply this by 1/3, multiply this by 1/3. And this is important. People often think that, okay, so then I've got this is pi over 6 is my new numbering for that spot. My new numbering for this spot should be negative pi over 6, right? Okay. And then the problem is, when asked what the period of it is now, they will typically say, oh, so the period of this is pi over 6, because they have these pi over 6's stuck in their head. But it's actually 1 pi over 6 this way and 1 pi over 6 that way, and therefore it's 2 pi over 6 is what its period is. Another way we could have figured out its period, 2 pi over 6 can reduce to pi over 3. Another way we can figure out that period would be to say the whole period used to be 1 pi, and now it is multiplied by 1/3 pi over 3, or 1/3 of a pi. If I take its whole period here, that goes from here to here, and the period is 2 pi is the other kind of function. For tangent, it's pi, so that's over 3, because it's pi over b, and the b term was 3. So period is pi over b is the standard form for it, and then again, the b term is 3, so then in this case, the period would be pi over 3. Okay, so what if you wanted to take your tangent and not just change the numbering there, but maybe you have tangent with a negative in front of it. Standard tangent graph. And now I'm going to take this negative, and it's going to flip it this way. That is a vertical reflection of tangent. But wait, there's more. Because if I had done tangent of negative x, inside one is a horizontal reflection. Do you get, if I take this red one and I do a horizontal reflection, that it's going to end up exactly the same as if I had done a vertical reflection? And that's because of one of those identities. Here's a way to at least show you that in a different form. the tangent of a negative angle would be equal to negative tangent of the angle, is like saying if I reflect it left-right, it's going to be the same as if I reflect it up-down. Or a horizontal reflection should come out the same as a vertical reflection. So do whichever feels more comfortable to you. If you think of this tangent, the red graph, as being a left-right reflection, and that works for you, cool. If you want to think of it as an up-down reflection, where I take the red one and take this part here, reflects down, and this part here reflects up. Either way, I end up getting the green reflection. So watch out for that on tangent, that both a horizontal and a vertical reflect will be the same thing. All right. So now I'm going to take a look at another kind of problem with you. I'm going to pause for a second. So here's the next page in your notes. This has two things going on. It's stretching the vertical. How are you going to do that on a tangent? Well, here's normal tangent, right? And here's pi over 2, and here's negative pi over 2. How do you do this 3? We didn't even have any numbers here before. Well, if you wanted to know where the numbers were so that we can now stretch them, if I said that that's where 1 was, and this is where negative 1 is, then do you get that this has to be the halfway mark of pi over 2, so half of pi over 2 is pi over 4, and that at pi over 4, it would be 1. I just said was that tangent of pi over 4 would be 1. I'm not doing this one yet. I got it, I'm just talking about regular tangent here. Okay? And tangent of pi over 4 is like tangent of 45 degrees, right? And I said it's equal to 1. Let's just look at the little picture there. Here is tangent of pi over 4, which is also known as 45 degrees. And that means this would be a 1, 1, 2, and wouldn't tangent of pi over 4 be equal to 1? Okay, so what that means is that one spot I didn't tell you about before, that you might need to know now, is that there can be a mark halfway across here, which can be at negative pi over 4, and would touch at negative 1. Why do you care? Because if you need to do this 3 in the front now, so now this 3 is going to do what it did on the other ones. The vertical messes with the vertical, and so this becomes a 3 and a negative 3. Okay, now I need to, last thing, do this 4 here. That, again, is on the inside of my function, and that means it's a horizontal, and it's not a stretch. You don't trust the things on the inside, so I'm not multiplying all of these numbers by 4, but I am going to multiply all of them by 1/4. So this becomes 1/4 of it. This becomes 1/4. This becomes 1/4, or multiplied by 1/4, and this is multiplied by 1/4 also. My new numbers are going to be pi over 8, pi over 16. That's supposed to be that spot right there. This one will be negative pi over 16. And this last one will be negative pi over 8. All right, and again, if you can't read this one, this is where negative 3 is, because it got stretched for that. All right, so it's the same basic process as before. I did want to remind you about this kind. I talked about it briefly, about how you can get it factored, but in this case, there's nothing to factor. So I don't really need to worry about factoring out a 1. It wouldn't really do much, right? Okay, they have a 1/2 on the outside already, so it's like they already factored out a 1/2. All right, so here's the changes on this one. Compared to normal tangent, I have to do a flip, and I would do that very last. I have to make my numbering here where it was 1 and negative 1. Got to multiply those by 1/2. So this becomes 1/2, negative 1/2. And then I have to go through and take all the numbers that were on this axis, which is mostly this pi over 2 and negative pi over 2 spot. And if this is where tangent normally goes, these numbers now have to get multiplied by not 1/2, but you don't trust it, do the opposite, multiply everything by 2. And this becomes pi over 4, negative pi over 4. All right, last thing to do, it needs me to shift it to the right pi over 2. And again, it's already been factored, so I don't have to worry about the whole, if you can factor it, you should. So that's moving to the right pi over 2. After I do the numbering, my numbering's already done here, and I know this distance right here is pi over 4. So this, if I shifted it over that far, would be moving it pi over 4. I need to move it pi over 2. So that is twice as far. So I need to move it twice that distance and move the whole graph over. And so I can grab this guy and just move him over that far. And there happens to already be asymptotes there, so that works out pretty good, and I can make more asymptotes down here. Okay, that's a little bit messy, but it's the same process as yesterday. Now, a little thrown in bonus, secant, to be able to graph secant and cosecant, I need to just give you a quick overview of what those will look like. All right, so tangent and cotangent are totally different than secant and cosecant. So let's go back to the ones that kind of go together. Do you remember that if we had sine of x, that there was a flipping sister for that? The flipping sister for that was cosecant. Now, that also helps in, let's say this is sine of theta is equal to 1/2. Then the cosecant of it would be flipping sister 2 over 1. Then that means their graphs are reciprocals of each other. Okay, so sine and cosecant are flipping sisters of each other. So if I want to go and look at what does secant look like, I first have to start by graphing its sister. So for secant, I'm going to go sister of tangent. No, not tangent, sorry. Sister of cosine. Secant goes with cosine. So the ones that go together again, sine, cosecant. Cosine, secant. And tangent, cotangent. Those are the flipping sisters, the reciprocals. Okay, so if I'm going to do secant, that's the one that goes with cosine. So I'm going to start by graphing cosine. There's my cosine graph. And I'll start labeling it here. -1. And this is pi over 2. Pi. Okay, hold on. This is 2 pi. That's not pi over anything. It's just pi. And this is 3 pi over 2. Okay, there is my cosine graph. Now, the secant is 1 over that. That means when this cosine graph hits 0, my secant is 1 over 0, which means it can't exist. So I have asymptotes here and here. Then the graph of secant is 1 over whatever cosine was. So here's where cosine was 1, and that means it's 1 over 1, which means it actually is the only spot that they share is right there. And then as this one gets smaller and smaller, that's cosine getting smaller and smaller, this one's going to get bigger and bigger. So this red graph is what secant would look like. If you were to graph it on your calculator, you wouldn't get this original in there, right? Because that's actually just helping us to draw it. This was the sister function. This was cosine. I'm going to take out this cosine graph now, and I'm going to just take out that little helper point there. And I didn't need that little circle. And what you have left, that's the graph of secant. All right. So how about cosecant? Cosecant is the flip of its sister function sine. So if I want to graph cosecant of x, it's the flip of sine. So here's my sine graph with, this is 2 pi, this is pi, this is pi over 2, and this is 3 pi over 2. And if I want to make cosecant, I got to first start with sine, and then wherever it's 0, there's going to be asymptotes. So there's asymptotes here, and here, and here, and then these are the only spots it'll share, because I don't know if you remember doing reciprocal graphs earlier in the year. The spots where it was equal to 1 and -1 are the only spots they share. Then, as this gets really small, this one gets really big. So there's these loops. And basically, it's riding on the back of the cosecant. The cosecant is riding on the back of its sister function, which is the sine function. So I'm going to get the sine out of here. Oh, all my other stuff stuck to it. I'll use my surgical eraser, a little tiny one here, and see if I can erase this out. Okay, so this green stuff that's left here, that is your graph of cosecant. And it was riding on the back of its sister function, which was sine. So this is really not part of the graph. I'm just trying to show you how to build it. All right. Then if we want to do stretches and stuff on cosecant, we got to do the same kind of things. If I multiply this by 2, then this spot right here that used to be 1 turns into a 2. And this used to be 1, turns into a 2 because of that 2. If I want to stretch it by putting like 2 theta here, and that's not a doubling, it's making it half as big, I multiply everything by a half, same deal, multiply everything by a half. So they act exactly the same once you know what the parent function looks like. All right, and the last one is cotangent. Cotangent is a flip of tangent, or it's a reciprocal of tangent. So I got to start my tangent graph. But it's easier to, instead of taking tangent's graph and flipping it over, it's easier to do this as, you remember the tangent was sine over cosine? Well, cotangent is cosine over sine. And that means that wherever sine hits 0, cotangent won't exist. So here's what sine looks like. Sine looks like this. And if I want to see where sine hits 0, it's there and there and there. And so that's where the asymptotes for cotangent are. And I don't need to make a gajillion of them. Cotangent just is a lot like our tangent graph, which the tangent, remember, used to look like this. Cotangent just goes the other way. So there we go. That's the graph of cotangent. I need to put in some labels of important spots. Remember how wide these are. These are 1 pi wide to start with. So this is pi. This is 0. And what's halfway between? Pi over 2. And then if I want to, I can put the spot 1 here and -1 here. And they would hit at halfway in here. So this would be at half of pi over 2, which is pi over 4. And this would be at 3 pi over 4 right there. And there's your graph of cotangent. All the same things could happen if we wanted to stretch it. Put a 7 out front. Well, then this has to be a 7, and this has to be a 7. And if I put a number in here, I could then cause me to renumber all of these spots. All right, it's a lot to learn for one day, but the lesson looks like it's gone about 20 minutes here, and you'll have the rest of the time to work on your homework. Let me show you what that is. Okay, here's the first day of the day 2 homework. Now, this is a lot like what we just did yesterday, where they've told you that tangent is x. So right away, I like to make my triangle in the first quadrant here, and tangent is opposite over adjacent, so x over 1. I could put it as over 1, right? And then that means this third side must be square root of this squared and this squared. So that's going to be square root of x squared and 1, and they're added. Cool. Now that I got that drawn, it's pretty easy to verify that cosine would be that. Look at that. I can just see it from this triangle. Cosine is adjacent over hypotenuse. All right? So now you can verify that this works, and this, and again, you'll need something off your sheet to do this, sine of 2 theta. All right. As far as cutting down your homework goes, let's just remove this one. Don't have to do part D. All right, over here, these are problems just like the last 2 days. It's just that now it's a tangent graph to start with. Again, your tangent graph, I put my asymptotes at 4 marks out. That's pi over 2, and that makes this negative pi over 2. And there's normal tangent. So now I can go, okay, what does that do? It changes my y-axis, which again I normally put at 4 marks up and 4 marks down. Those numbers change because of this. This 2 tells me to make that a 2. That's a negative 2. And this is going to make me renumber it, which is going to make me not multiply everything by 1/4, but multiply all these numbers by 4. All right. Then it's A, B, C, and D. That's the A. That's the B. There's no shift in here, so I can put like there's a +0 in there. That's the C, and then that is the D. So A was 2 in this case. Better color here. A was 2. B was, instead of 1/4, no wait, we do use 1/4 here for the B term. Sorry. For our period, we'll do the flip thing. Part C is 0, and part D, that is -3. Okay, the amplitude then is 2, because it comes from this. The period, well, the formula for period is pi over B. Why pi? Because tangent has a smaller period of just pi. So pi over B, pi over 1/4. That means, again, you don't multiply by 1/4, you multiply by 4. So pi over 1/4, which is 4 pi, is its period. And then the horizontal shift, there was none. That was this part. The vertical shift was that part. It would be right. No, wait. Vertical. That means down 3. So I haven't actually done all those changes to the graph. You have to do that. That's your job. All right. Let's make this a little more reasonably sized here. I'm going to have you skip this middle one. Let me skip this guy. And then we'll have you do 23 at the bottom of the page there. Okay, and then on this page, didn't have time to explain these to you. These are really tricky ones, and I'm going to have you skip them. And then this one is a good example of how we can make this into an R3. It's really not too tough. Granted, you want to move this to the end, but then you've got your A term here, your B terms in here. It hasn't been shifted at all, so there's no C term. And then this is the D term at the end. And it's just use what they've told you here to try to answer number 5. That's a good one. And then in here, also skipping this section here. All right, that's all I have for you for the homework for today.